Experience tranquility as you drive through the population-free lush green slopes of Vaknakat Sulan. To reach functionality and aesthetically spread 25 25 acres of easy-flowing and community-friendly landscape. Welcome to JP University of Information Technology, Wagner Sulan, set up in 2002 under the Extraordinary Gazette Notification of Government
A very good morning to one and all. We'll begin maybe in next few minutes, just waiting for our guest speakers to arrive. We'll begin shortly as our guest speakers arrives.
Yeah, good morning, Ashwani, Bamba ji.
Good morning.
Good morning, Ashwani.
Good morning. Good morning. Good morning.
A very warm welcome from the JUIT family. Thank you for accepting our invitation to be our guest speakers this day.
Can we start?
We are waiting for Jagjit sir also. If he will be coming. Neeraj, can you confirm?
Okay.
We're just waiting for our session address, Mr. Jagjit Singh. If he's here, then we'll start the program.
Sure, we can do that.
Yes.
Tanvi, we can start the proceeding. Mr. Singh is stuck in a meeting, so he will be joining a little late. But we can start with Mr. Bamba right now.
Sure.
Yeah.
Thank you. Thank
So
you for your
we can
confirmation.
start the proceeding.
Thank you for your confirmation.
Thank you.
So a very good morning to one and all from the foothills of Shivalik, from JP University of Information Technology, to this webinar program on latest trends in green buildings, and which has been conducted in coherence with IGBC Chandigarh Chapter and on the auspicious occasion of World Green Building Week, which has been celebrated from 12th to 16th of September 2022. So we are very fortunate to have three eminent speakers who have been working with green buildings since such a long time. And today we will be having their expertise shared with us. Just a brief about the JP University of Information Technology and in specific about the Civil Engineering Department here at JUIT Vatnaghat. Here we offer two BTech degree programs which are in civil engineering, and another program which we have launched this year is of civil engineering with computer applications. This curriculum has been specially designed to keeping in view the emerging civil engineering needs of the country, as well as the modern emphasis on the IT-enabled civil engineering services. Further, at master's level, the department offers two MTech programs in construction management, environmental engineering, and in structural engineering. In addition to a PhD degree is also offered in the areas of geotechnical engineering, structural engineering, construction management, hydropower engineering, environmental engineering, and water resources. So coming to today's program, which are the latest trends in green buildings, I'd like to invite our first speaker, Mr. Ashwani Bambaji, who is the Director of Quick Logic Controls. He is a first-generation entrepreneur, graduate from PEC and MBA from UBS Chandigarh. He is a strategist and passionate to promote new technology for better control and energy efficiency. He is expert in exploring new opportunities to carry benefits to technology for mass adoption, evolving through the past 32 years over newer applications spread across business segments of industry, infrastructure, residential, and commercial space. Over past 2 decades, he has been in the buildings control space and is keen to share his experience and learnings today with us. With these words, I hand over the stage to Mr. Ashwani Bambaji to give his brief presentation on role of integrated building management systems and latest trends and technologies. Over to you, sir.
Good morning, everyone. I'm as I was introduced. It's a privilege to be a part of this session to share my experiences with the audience that we have today. And as it was stated that I have been into this space for last more than 20 years, exploring newer applications wherein we can add value, to the users, be it industry, be it commercial buildings, be it infra buildings, or be it residence also. When we started, it was automation was a very, very unfamiliar term for general public. Today, it is a part of our daily life. So I start with the subject, and I will, take you through the entire journey, right? So I just share my screen now.
Sure.
So is it visible now?
Yes, sir, it is visible. You may do it, may maximize the same.
So to begin with,
Sir, I'm sorry to interrupt in between. You might have shared only the PPT screen, so we are still able to see the full PPT, not the full screen one. If you can share your entire screen through this present option, then we will be able to see what you are seeing on your screen. Currently, we are not able to see the full screen slideshow. In the present option, if you can just go through present entire screen, your entire screen, then whatever you will be able to see, we'll be able to also see.
so is it now visible, the entire screen?
Yes. Yeah. Now it's great, sir. Thank you so much.
Okay. So we begin with the presentation and a role of integrated building management system, latest trends and technologies. First, the objective of this presentation, we know we have evolved over these years of a comprehensive solution to managing the utilities and the services of our building. However, we have faced challenges over this period, and that's something which I would share with you in this presentation. And eventually, what are we doing to improve upon what we have, and what are the disruptions that are taking place in the industry? So we get started with the contents. We'll go through. Rather, won't spend much time on discussing what an integrated building management system is, but we'll put our focus on points 2 and 3, wherein the typical approach that is being followed till now, what challenges it is creating, and how do we reach a point where system delivers and reaches the potential users. So to begin with, what is the intent of a building management system, or what you call as integrated building management system? I would say we try to derive majorly 4 benefits out of it. First is improving the efficiency. Now it is efficiency in terms of the deployed resources, utilities, in terms of the performance of the equipment. Second aspect that we cover in the building management system, that is, we want the equipment that are there in the building, they are safe, and the users who are operating them or there in the environment, they are also safe. The third aspect is related to the comfort of the users of the building and providing them with a healthy environment. And the fourth is providing connectivity. Now, connectivity, what I mean is that these systems can be exploited to their highest benefits if the appropriate connections are there in the environment within the building and outside the building also. This slide would give you the kind of comprehensive services that can be covered through building management system. It is the principal part you would see is the utilities that are there in the building, the HVAC, the electrical system, the plumbing system, the other safety services, like you have the fire alarm system, the CCTV and access control systems, which are providing the appropriate access, And then we have the other data services which provide the required interconnectivity. And that's how, the best out of these building management systems can be derived. So most commonly covered services in an integrated building management system is air conditioning, ventilation, lighting, access control, CCTV, fire detection and firefighting, lifts, plumbing, electricity distribution, and energy management. So when we design a building management system, we figure out the hardware required to connect these services to the users so that they are able to get the best out of them. So in this schematic, if you see, you have the BMS hardware, you have servers and user interfaces, which are used to have the required information. There are networks which are in the shape of our networking solutions, and the cabling. Then we move on to the BMS hardware part, which are in terms of the controllers that we have, and then the sensors and actuators, what we call as field devices. These are then interconnected with these controllers, and eventually the inputs from the sensors reach the controllers, and the logical functions for which these controllers are programmed, they are executed through the actuators. In addition to this, we have the networks through communication standards or protocols, which provide the soft connectivity, the soft points of different systems. We go on to the services that we are catering to. We would have solutions covering chilled water plants, cooling towers, condensed water, heating water plants, exhaust systems, ventilation. This is typically for the HVAC part. And this is where, we try to work on the air quality and the temperature conditions or humidity conditions, which are required to be maintained. Now, when we say integrated building management system, again, we say typical systems which are integrated with the BMS systems are lighting systems, emergency lighting systems, fire protection and security systems, CCTV, metering solutions, and the other conveniences like the services in typical like elevators, escalators, right? So these all systems are interconnected in the that if there is any alarm, for instance, from the fire alarm, we are able to condition the other services like access control or the HVAC so that the damage is controlled or minimized or avoided. These are some of the user interfaces, how the data that is generated out of BMS is presented. It could be in the shape of through a graphical user interface. It can be in the shape of dashboards. It can be in the shape of graphs. It is through alarms and reports that we get the required information of the events that are happening in the building. Now, what benefits we target through BMS? We are able to monitor all the systems in the building on real-time basis. We are able to customize controls so that they suit us most appropriately. We integrate all the building systems on a single platform. If there are failure of certain equipment, we know what is the remedial steps that we need to take, and that can be designed to be automatically taken care of. We are able to reduce our operating and running costs, we are able to, reduce our manpower cost or the labor that is required to be deployed. We increase the comfort, we improve the air quality and other services. And as I said, safety and security. And last but not the least, the data generation, which is used for required analysis to improve upon the system and the services covered. Now, the basic thing where I really wanted to focus this presentation was on what are the challenges? First, let us understand what is the approach that we follow. The approach when we implement a IBMS project is we start with the project identification. There are stakeholders, consultants, and BMS product OEMs and contractors. They get together to work on the identified opportunity. The tenders are made, the IO summary is prepared, the equipment list is done, the budgeting is done, and the schedule of implementation is decided. Then, in the process of implementation, you start with detailed drawings, shop drawings. Then there are, coordination. You start with the coordination with third-party vendors for coordination and provisioning. The physical work starts with conduiting, cabling, then sensor installations, then equipment installation, terminations. Finally, we reach the point where programming and integration is done to hand over the system to the user. Now, if you see the entire process, this typically takes 2 to 4 years. That is the experience. When, particularly, when we're targeting BMS, till now, it has been focused on the newer buildings. So newer buildings means the entire construction phase, plus the design phase before the construction start, plus the handing over stage when the user is already inside the building. Now, this entire phase is when the entire BMS activity is being carried out, and this span is pretty long. It is in most of the cases it runs into years and years. Right now, the stable managing of the process during this long duration itself is a big challenge. Right. So what are the expected issues we face? There are issues of coordination with various agencies. There are cost and time overruns and cash flow issues. There are certain hardware and software upgrades that are in the process of this long period, they may have come up. Some of the part of the hardware or the software might have gone obsolete. Now you also have to deal with that situation. And then there are changes. People change at site, people change at the integrator level, and the entire exercise further complicates the entire thing. Now this all leads to compromised commissioning and handing over of the system. Now, post handing over, what are the challenges? So, if you do not have the competent and stable manpower at the end user, what will happen? The handing over itself will be improper. The people who are taking over the system, they are not adequately trained. This inadequacy results in poor commitments and lack of understanding of the system. This further results into casual handling, systems would break down. Now, if let's say there's an event taking place or the exercise going on or the building systems are in use, typically these people would tend to, bypass these systems, and the entire worthiness of the system and the trust in the system itself is lost. So what are the remedial things we need to do? We need to take care of all these, particularly the time frame, and if we are targeting only the new buildings, we cannot do much about it, right? So what are the issues that we're facing? You see, barring exceptions, IBMS is always considered for new and large buildings. Existing buildings practically do not have BMS at all, and there are no proposals for smaller buildings considered. Almost every detail needs to be planned in the initial stage, like the budgeting. You have to go into the minutest of details to avoid complications in the course of implementation. The design stage becomes very critical, right? And the kind of, once we have decided the product, the scope, upgradation becomes a challenge, and it is sure that these cases would come up when we have a very long duration of the implementation. So the third is that you have to make budgetary provision right in the beginning itself. So mostly, this is dropped or limited owing to the high one-time investment that is required. Now this the limitations begin from design stage and they go on till the handing over and the end user. So what do we need to do? What do we need to do in the context of these compromises that we are facing? So we need to look at the newer trends. We are requiring to understand what the current challenges are, and we need to customize our offering in such a way that it delivers what it is intended to deliver. So let's say some of the concerns is sustainability. So through BMS, what we expect is higher energy efficiency, lower operating and maintenance cost, better indoor air quality, greater comfort and productivity. Now, these things would help us to achieve the sustainability in the building environment. And that's how we connect building management system with sustainability. The second aspect today, which is under focus, is clean energy and carbon neutrality. We are declaring, we are making serious declarations about getting carbon neutral over the years. Over the years to come, India itself has given commitments, right? So what BMS can contribute? It is again, improving indoor environment, improving on the operation and maintenance, minimizing energy consumption from renewable resources, protecting and conserving water. Now, all this would add to our carbon neutrality targets of carbon neutrality, right? So again, the next thing that we are looking at as we are entering, we are now deep into subjects like artificial intelligence, right? So we are looking at improved. Now in larger projects, we are looking at, a better asset performance. We are wanting to have predictability as to how the equipment or the system is going to behave over a period of time. And then ultimately, we need to have a proactive maintenance plans so that the panic is avoided, the breakdowns are minimized, we are able to come back to a normal in the shortest possible time and minimize damage. Then, the biggest thing which I really want to mention in this session today is the benefits of technology should reach maximum potential users. So when I mean maximum potential,
sir, I'm afraid your mic has switched off. Maybe. You can just open a Google Chrome screen. From there, I guess mic has been switched off. Yes, sir. You can turn it back on. First icon.
Yeah.
Now it's on. You can again move back to PPT. PowerPoint. Second last one. Next one to this. Yes, you can go. You can maybe full screen it again.
Is it fine now?
Yes, sir. Thank you.
So my discussion was at this point where we want IBMS to be part of every building, every significant building. Right now, the situation is that it is not even a fraction, not even 1% of the buildings, they are able to have a building management system and take advantage. See, most of the time when I interact with people, I just ask them, do you have a BMS system in the building? And when they say, yes, we have, I just ask them, is it working? And the answer most of the time is either no or it is compromised. And then this is there in less than 1% of the buildings. Whereas we have very large buildings, they are put together, they are consuming a huge amount of energy. All the aspects of VMS, they are deprived of just because of the complexities that I enumerated in my earlier slides. So what is the solution? I would say one of the solution is wireless IoT-based IBMS. Now what it does, we have controllers which do not require any wiring for.
I'm quite sorry, sir. Again, it happened. Your mic got turned off. I'm not understanding how it's happening. Now it's on.
Yeah. So, what do we have in my? So I was talking about the IoT-based BMS solution. So what it does, it is simple to install. It is reaching out to all the retrofit cases, that is the existing buildings. It means 100% of building which have a significant HVAC or systems or other services are kept, these services can be extended to these. Installation can be completed within days. And when you have a very short time frame of implementing, from the day we identify the opportunity till the time we are able to, deliver the system, if it is within days, I believe a lot of complications and unforeseen challenges can be taken care of. The biggest achievement is it doesn't require too much of expertise at the site, neither from the installer side nor for the operator. So the user does not require too much of expertise because entire solution sits in the cloud. There are no costly licenses to be maintained, IT hardware or servers, or the storage for data that is required. So this makes the use of technology simple even for a common user. And that's the best outcome of this solution. Now, I'll just share a slide showing how it is like. This is what kind of a network it would be. We are catering to all these services. It is a cloud-based solution. You would have gateways, and these gateways are connected to controllers, which are connected to individual equipment. Now, these gateways and controllers do not require any wiring in between, and these gateways are then transmitting the entire information over the cloud. So result is, the moment you identify an opportunity, you identify the status of the unit over there, the status of the system over there. You design your hardware and sensors, and then finally take a short breakdown, shutdown, and within few hours, you can implement it on a particular equipment. And the moment it is connected to the gateway, you just have to open the browser, put in username, password, and you are there. So it gives you all the controls that you require. It gives you all the data logging. So no designing or no programming, real programming at the site is required. This is how the life of the user and the implementer is simplified. And this is how the benefit would reach out to its intended audience. The players like Siemens, Schneider, Honeywell, they're coming up with IoT-based BMSs, and they're starting with smaller installations, smaller applications. But just to tell you, there are players who have implemented thousands of IBMS systems which are wireless, and they have reached a level wherein they can even in the industrial applications, they can comply with the requirements of CFR 21 Part 11 to that extent. It offers you solutions like clean room applications. It offers you elaborate solution. It targets, in HVAC, it targets through delta T management the real energy saving on the chiller side. So just to emphasize the point that it has reached quite a bit of maturity, except for very high complex requirements which are numbered. Rest of the things can be taken care of. And this is something what has started causing disruption in the IBMS market. So a system which was designed for all these years, BMS is in the market for last 30-40 years, but the benefits have not really reached the end users in an appropriate manner. Now is the time that we leverage these newer technologies and make sure that BMS also becomes a household word. With all this, I finish my presentation. Thank you very much.
So thank you so much, sir. And this was a very interactive and very eye-opening presentation. How much we have come forward into BMS and how much more can be done to reach it to the mass level. So I had a simple query. So if in certain buildings which have been already constructed to retrofit such integrating devices, what kind of sensors are present in market which are cost effective also for a certain middle class person also to implement in their devices? Because there is a lot of confusion or this kind of mentality is going on that these integrating sensors are of quite high-end users only, not for in a massively available way. So if you can give some
as my experience goes, the systems that are the way it is being promoted is now what we really want is that the system should be functional at the shortest possible time. Yeah. So the typical OEMs tend to offer sensors along with the controller. So it becomes a package solution. Now, when you compare this package solution with the available IBMS offers that we have in our in the conventional approach that we have been following till now, the cost of this solution per equipment is at least 30-35% lower. So when you really, rather than going into individual sensor costing, because when you even in the industry, when you see for the same purpose, the range of dependability, quality, cost of sensors from different makes with different specifications, it's very wide. Yeah. So what is the purpose of giving sensors along with these controllers is to have a calibrated solution. You're worried about calibration of sensors. A sensor is supposed, let's say a sensor is supposed to measure temperature. Okay. Now, if it is properly calibrated, if it is showing 30 degrees centigrade, it should actually be 30 degrees centigrade, right? So that hassle of calibration, we just want the uncertainties, the causes which can, create challenges, those are eliminated right in the beginning itself. So typically, if I tell you about one of the OEMs, he supplies not just the sensors, he supplies the connecting cable also between the controller and the sensor as a single package. And that again is, with the intent that the quality of cable is such that he is sure that whatever, signal it is transmitting, it does not get, diminished, or it doesn't get altered just because there is a higher impedance chosen.
Correct.
Yeah.
Because maybe you can mute yourself. Sorry for the interruption. Yes, sir. So that's how what you were saying is the emphasis should be on a calibrated device. Then only we can get
Calibrated.
actually the current measurements.
Yeah, calibrated, dependable, and cost effective as an overall package.
Yeah.
So just to tell you one thing, just to make sure that the concerns or the apprehensions of the possible users are addressed, now is the time where whosoever serious about this and has got a decent amount of equipment to be covered under BMS, and he wants to improve his systems availability or the performance or the energy efficiency. OEMs have started offering POCs so that proof of concept is demonstrated right in front of them. We are able to, sitting at our locations or the OEM's locations, we are able to reach out those users particularly who permit us to demonstrate the system to the potential users. You are just required to log in to those systems and you are able to demonstrate the benefit. And as I said, as the faith level goes up, I remember a time when products like variable frequency drives were still in that conceptual stage, particularly from energy saving prospect. So there were, solution providers or integrators who had made up panels, one side variable frequency drive, second side star delta starter, and then in between an energy meter. And they would take this panel to the users and say, just install in one of your ID fan or FD fan or any of your equipment, where any of your centrifugal devices, and see for yourself. Within days, you will realize the amount of energy saving that this VFD is going to bring it to you. So the same stage, I believe, is now for IoT-based BMS. And probably there are OEMs who are taking initiative on this.
Yeah, there are lots of startups coming even from our students' practices we are seeing here also in various parts of different colleges, that they are coming up with different efficient solutions which are having lesser shutdown time and having a lot more efficiencies.
I will share my personal experience. Yes. We did one POC at Aikar Bhavan, Chandigarh. Though, these installations are in thousands, particularly in southern and western India. But we did one POC for the northern customer for a CPWD owned building where Johnson Control IBMS was installed and was non-functional for last couple of years. Right. So we picked up one AHU and we decided to do a POC. We started after lunch, and before the office was over, we could show them that remotely how they can switch on and switch off the machine and see the relevant parameters that are to be monitored. So I think this is something which is it's not much of a time that the user would require to spare and stay worried about loss of productivity because of the shutdown. This system can be delivered in very, very short times.
So one last question we will take. It's from Mr. Abdul Rafi. He's asking to what extent in percentage India is implementing IBMS compared with other developed countries, if you can put some light on it.
I feel IBMS is being specified in all the major buildings that are coming up these days. As I said in one of my slides, IBMS till now has been targeted, and probably this is true for the developed countries also. When we are talking about the wired solution that we have been implementing till now, it has been true for other countries also. It has been true for India also. that it has been offered only in the new constructions coming up. So if you look at the pace of construction that is going on in India and compare it with any of the places in Europe or North America, or to say it, developed countries, the number of buildings that are coming up in countries like India is much, much larger than the new constructions we are taking up. I read about one study from McKinsey which said every is. So as of now, the implementation in developing countries is much higher than what we see in the developed countries.
Yes, sir. I hope this answers the query. With this, we once again thank you so much, sir, for your valuable time. And we heartily invite you to come amongst the foothills of Shivalik sometime to visit it at JP University. We'll be having a lot more intellectual discussions in this regard.
Thank you so much. Thank you so much.
So with this, I'll like to invite our next speaker for today. I'll just share his credentials once. So our next speaker for today will be architect Sukumar Jairath. He is the principal architect for the Studio by Design. He is a first-generation entrepreneur, graduated from PEC and an MBA from UBS Chandigarh. He is a strategist, and Sukumar Jairath, sir, is very sensitive young architect who has been working conspicuously drawing attention to the dynamics of space and form. His strength lies in creating a new architectonic vocabulary where form and function are never independent of each other, but exist in a synergy that addresses the client's requirement and the site-specific considerations. He is currently the director of Studio by Design, Art and Architecture, and also vice chairman of Indian Institute of Architects, Panchkula Center. He has undertaken numerous commercial, sports buildings, residential, industrial, institutional, and landscape and interior design projects all over North India and overseas. Sir has done his B.Arch and MCA. So he will be giving a very wonderful talk on Walk the Talk on green buildings, not just the theoretical aspects, but what are the present aspects. So with this brief introduction, I like to invite architect Sukumar Jairath ji to give his brief presentation.
Thank you, Tanmay. Thank you, Tanmay, for the very warm introduction. And that was, this is talking to the students is something which is always heartening and always welcome. So a very, very warm welcome to all present. As architects and civil engineers, we are blessed actually. We are blessed, somewhat to be in the same profession as God himself, as creators, to be able to create edifices that would long outlive us and to be able to make our signatures on the planet. This gives me a tremendous feeling of achievement and satisfaction. In today's times, we have a huge access to all the technology, and we take pride in designing buildings which are visual symbols of our creative skills. But we all know, the first dictum of architecture, which is form follows function. So in our, in our intention to create forms which are visual symbols of our creativity, we sometimes tend to avoid the functionalities of buildings, which is very, very important and something, which has come to be seen as so strongly in the present times. So since the buildings are huge guzzlers of all the resources, we need to be very, very aware as to what type of buildings we are designing and what are their impact on the environment. Talking about Himachal, I have a lot of affinity for Himachal. My parents were educationists. They were teaching in the Himachal University when I was a kid. And ever since, I've been very, very close and very, 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 very attached to the hills. I have a small place for myself in Dharampur, near to where your college is. And when I took up that place, I wanted to do something which was as inconspicuous, as subtle and as laid back as I could, to blend with stuff and all. So when I would invite you to come to that place sometime, it is very unassuming. It is very simple, not at all loud and proclaiming itself. But this is a place where one can use, which one can use for the entire year without ever, whether it is summer or winter or something. It's never harsh, and it is always, energy point of view, say it is very, very friendly. IGBC, actually, I've not been into green buildings for a long time. IGBC is what I ventured into just a couple of years back when I attended this IGBC course. And then subsequently, after being familiarized with all the aspects, I got this IGBC accreditation. I got this IGBC professional degree. And then the next building which I did, we are working for the Chitkara Educational Trust, Chandigarh. We're doing their educational institutions in Himachal and in Punjab as well, in Chandigarh too. And there was this new school building which they wanted us to do. And I thought that, this was the time I should get this thing building, get this building into a green building. That was our first attempt, our first formal attempt at green architecture. And so consciously, I'll just take you through the entire process, the entire set of things which we adhered to and which we took care of while designing and implementing the building. And with God's grace and with IGBC's support, we were able to get a platinum rating, a very coveted rating for the first building. And I'm grateful to the IGBC for having handheld us in the entire process, and also to our entire team in the Chitkara University, which gave its consent and enabled us to do the building in the way we wanted it to be done. So I'll just take you through the process, and I'll familiarize you with the all the aspects of that.
Sure.
Yeah. So this is the school building that we did. I mean, we wanted it to be architecturally, we wanted it to be a structure which would, be a landmark and which would, basically make its presence felt. So that is something which the client also wanted us to do. So this is a building which architecturally, gives you a character of being a model building. It has certain elements to it which are symbolic of education, and you see these inverted pencils here. You see these alphabets here, which basically again speak of education. So when we do I'll just now talk of the green aspect of it. Now, when we do a green building, there is a very structured format we need to take care of. The elements which you see outlined in green are the aspects which are to be taken care of, and each aspect has certain subpoints which have some points attached to it. So when you attempt these aspects and you give relevant documentation of having conformed with all the activities connected with these aspects, you're able to get those points. And if you get a specific number of points, you're able to achieve that specific rating. So the aspects are site selection and planning once. So in that aspect, there are
sorry sir, to interrupt you.
Sorry.
So if you can just a little bit zoom it in to the document, we'll be able to see better.
Okay,
right
sure.
now it is in 100% mode, so the visibility is little low.
Okay, is this better?
Yes, sir. Great, sir. Yes, great. Thank you.
All right. Yeah. So this is, when we talk of the first element, this is site selection and planning. So in this aspect, we are looking at the topsoil preservation. This is very important, and this is the credit one, which is to be seen whenever we are excavating, we need to preserve the topsoil so that we are able to use that topsoil. Since it's a fertile soil rich in minerals, we need to we need to save it so that we can use it subsequently for the landscaping and everything. And in the site selection, the second aspect is eco-friendly commuting practices, so that there are not too many vehicles which are required to be used when you use this place. And so the parking and the pollution issues are addressed. The parking capacity has to be adequate. We have to make sure that the design follows the parking norms and it provides for the parking in that way. We need to minimize the heat exposure to the sun. Now the heat exposure is basically through the roof and the non-roof areas. So that is something which we need to conform to. I'll come down to the details later. And the universal design, which basically means that all the people, whether they have certain Again, turf design. Turf design means what is the amount of grass which you are using. Grass, happens to be a guzzler of water. So you need to be careful as to what is the amount of grass that you are planting. Water efficient landscaping means that whatever are the landscaping practices and the landscaping, the watering of the landscape, we need to be aware of that. Water efficient irrigation system and water use monitoring. Then the third aspect is conserving and harvesting of energy. Again, the energy harvesting is done by the use of energy efficient fans and energy efficient fixtures, energy efficient appliances, metering, sub-metering, on-site renewable energy usage, and solar water heating systems. Again, all these are to be illustrated and demonstrated in the IGBC report which you need to submit. If you have a proper demonstration of all this, you will be able to get the relevant points which will add to your rating. Eco-friendly materials need to be used. In that, the organic waste management needs to be followed. The use of local materials also is important. Then the next aspect is indoor environmental quality, in which the areas of each classroom, in case of an institutional building, need to be seen whether they are commensurate with the type of usage of the the number of people which you are using the classroom for. Anthropometric dimensions of spaces means that the furniture and the other elements in the interiors are of the same size and scale as the users are. So in this case, we were very conscious of that. We designed the furniture also in the manner that each classroom, each occupant, the size of each occupant is taken care of while designing the furniture as well. Daylighting is a very important element in indoor environmental quality. So you need to make sure that the quantity of daylight which enters the room is adequate. So fresh air ventilation is also very important. Toxin-free environment, dust-free environment, exhaust systems, and building flush out. Building flush out is that when you have constructed the building should be freed from all the toxins which might have entered during the process of the construction. Health and hygiene. Now the next elements are basically for the administration to do. Architecturally, it's not a part of the architecture too much, but the administration needs to take care of the health and hygiene elements, which means access to healthy food, minimal sports amenities, dedicated playground, organic fertilizers by pesticide, green housekeeping. Then green education is also a part of the requirement which is there for us to get a green certification. And there also, if there are any innovative practices in terms of practicing of green certain activities which are indicated towards green buildings, so that is also something which is always required. So these are the verticals basically on the basis of which a green building is analyzed and evaluated, and on the basis of which the accreditations are granted. So in the first case, when I'll come to the first thing now, the local building regulations. Now, any building which is supposed to have a credit of green architecture, an IGBC rating, needs to be conversant or familiarized or following the laws of the local building.
I'm sorry, sir, we lost your mic connection. We are not able to hear you, Sukumar, sir.
Hello? Hello?
Yeah, yes, sir. Now it's audible.
Am I audible?
Yeah.
Okay. Okay.
Thank you.
Okay. Yeah. So these are the documents. I'll just maybe illustrate. They're not very relevant, but I'll just illustrate them to you. So having these, like the possession certificate, the building approval certificates from the local authorities, site plan, all the floor plans and the area calculations. These are to be deposited to the IGBC for them to see whether you have complied with the local regulations and the building is as per the local bylaws and all. So for topsoil preservation, these are certain pictures which are of our project, which are indicative of the fact that the soil which was excavated was preserved and stockpiled, and then subsequently it was used for the landscaping. So you need to demonstrate through pictures that the topsoil, which in our case, was up to a depth of 10 inches, we have basically used that and finally used it in the landscaping. Now, in the eco-friendly commuting practices, we needed to demonstrate that 50% of the students and teachers will, more than 50% of the students and teachers will transit by school bus. So for that, we gave in a declaration. The parking capacity, the in-house parking capacity of the school buses was to be demonstrated, which we demonstrated, and the adequate area was taken care of by us. Then the next element was the minimization of the exposure to the sun. So we need to design in a way that the terrace areas need to be minimally exposed to the sun, and whatever are the exposed areas, we need to cover those areas with roofings or tiles which basically are painted or are provided with reflective facility, which adds a minimal heat load to the building, and the air conditioning system is also not very heavily, it is not heavy. Universal design in our case was taken care of by adequate ramps which provided the main access to the school building, which had been demonstrated here, and the ramps of the slopes are also to be taken care of. 1:10 is the minimum slope which we need to provide for entry and exit. Besides giving the required or the designated slopes to the ramps, we also need to provide for universally abled people who have some handicap, and we need also to provide a lift with braille assistance to be able to take care of the specially abled places, people. So with all these things, we need to, provide documentation. In this case, these are the documentations in this particular site plan. We have to provide it for the earmark the parking place for the people with a handicap. And accordingly, we have also provided the documentation regarding the location of the restrooms for the physically challenged. And the ramp locations, like I showed you in the pictures, have also been defined in these drawings, which we presented to the IGBC to basically assure them that this is what the provisions have been done. Now, when we look at the rainwater harvesting for the roof and non-roof, there are certain formats of calculations which we need to describe. So we need to basically first calculate the amount of rainfall which is there in that area on the basis of the data provided by the IMD. And then we need to describe as to what is the harvesting which we have done of the rain which we have been getting over 1 year of time. So all this is done by calculations, and in this case, just these are the calculations. These are certain pictures which have been, which are of the rainwater harvesting system. And at the end, we needed to basically describe that, based on the area, we have been able to recharge 80% of the peak hour rain runoff. So this is very important, that whatever is the rainfall area, whatever is the rainfall that you get on site, what is the type of recharging of the rain or the groundwater that you are doing in your school campus. Then these are the type of surfaces. These are, there are certain surfaces which are cemented or tiled. There is some open grid concrete pavement, there's some artificial turf. So all these surfaces have different percolation coefficients, and all these surfaces have different amount of water absorption. So as per the runoff coefficient, we have this calculation done in which the calculation of the runoff of water is calculated, and this is how we have demonstrated that 80%, 87% of that total runoff water has been harvested by us. So these are certain documents which come from the people who did the rainwater harvesting pits for us. So in our case, there was no proper green grassy playground. So grass happens to be a guzzler. So we have this artificial turf on our campus in which we have used for the playing activities of the kids. In the water efficient landscaping, we have used all the native and drought tolerant species, and we have indicated all these species in the document, and basically 100% of the vegetation or the landscaping that we have done is by using the drought tolerant species. We needed to attach a plan which showed the type of plantation that we did. Again, the harvesting, the irrigation system needed to be done, through a process which minimizes the wastage of water. So in our case, we have used the drip irrigation, and wherever irrigation is required, minimal water wastage is there. Waste water treatment has also been done by us. The STP takes care of the usage of, basically the cleaning of the sewage water that came out of our site. And the use of treated water is being done for the landscaping, and the we have also given some water to local people for watering. Water use monitoring was done by us. Again, this is something which is normally done. So eco-friendly refrigerants had been used in the campus. And then energy efficient lighting fixtures were used by us. So basically we needed to demonstrate what is the type of saving that we do by using energy efficient lighting fixtures. So for each and every area that we did, the amount of energy efficient fixtures which we have used, the energy consumption, and the energy consumption which we have done by using the energy efficient fixtures have been demonstrated by us. So for all the flows, the base case scenario and the proposed scenario for all the flows has been given to them, and on that basis, the demonstration of saving 68% of energy vis-a-vis the conventional lighting fixtures has been demonstrated by us. So that is what is to be shown to the IGBC for them to understand what is the energy saving which you are doing by using energy saving devices. Again, by the use of ceiling fans, all this calculation by using fans have been described. Also by using other appliances which have a BEE green 3-star rating or a 4-star or a 5-star rating. All this, these are the various indoor spaces of the school. The air conditioners and all that, the refrigerators and all, they also are. Energy sub-metering is also done. So in our case, I'm not an electrical engineer, so I'll not be able to get into much of this. But basically, the plant at the school, the sub-metering was done, and this was the PCC panel in which all the sub-metering was done, and the energy efficiency was taken care of. Now we have also tried to have renewable energy on site. So we have a 50 kilowatt solar PV plant on the roof, and this all this solar PV on the roof basically takes care of that 10% of the total energy demand is generated by the use of renewable source of energy, which are these solar panels. Waste segregation also is not a very complicated thing to do. So we have taken care of the waste, the dry, the wet, and the paper waste to be provided for and collected independently. Solar water heating system is given on site. Organic composters are given, and the management of organic, the preparation of organic compost is provided for. Then another thing in green buildings is the use of local materials for construction. So the aim behind this is that we should not be requiring to have a lot of transportation cost or pollution involved in getting material to the building site and accordingly using it. So we need to describe to the IGBC as to what is the distance from which the various building stuff is procured, and accordingly the bills and the documents for all this needs to be submitted to the IGBC. And in our case, we were able to provide for almost 60% of the material locally. Locally means within a radius of 40 kilometers. Then tobacco-free smoke control is taken care of by us. So we need to provide all these signages on site. Now, coming to the minimum daylight requirements in the room. So for each classroom, we need to provide a minimal daylight factor, which is 2.5. So in our case, we exceeded the minimal daylight factor. We were at 2.95 or 3.14 in most of the classrooms. So for all the floors, we had to describe the number of classrooms and the number of regularly occupied spaces, and accordingly the daylight factor we needed to provide for on all the floors. Now the daylight factor is to be carefully balanced with the amount of heat which is entering the rooms. So in our case, the selection of glass was done very carefully so that you get the amount of light which is required, but you don't end up getting too much of heat inside the building, which adds to the air conditioning load. So for all the facades which we did, we selected the glass appropriately so that we are able to have a balance between the amount of light and the amount of heat which enters the classrooms. So solar control glass, we did a simulation and the solar control glass was procured accordingly. So for the fresh air ventilation of each and every classroom, we are required to make sure that 30% of the openings are provided compared to the carpet area of regularly occupied spaces. So if you have 100 square foot of carpet area, you need to provide for 30% of the openings which are openable. So openable means that they should be able to let in air and oxygen. So that is something which we need to demonstrate. So the openable areas, vis-a-vis the carpet areas, need to be demonstrated for IGBC to know that you are letting in proper amount of air and the ventilation is proper. So these were the fresh air calculations that we submitted to them for all the floors, for all the occupied spaces. So we were at a 30.4% of openable area for the regularly occupied spaces. Then the area of classroom per student also needs to be shown to them so that the spaces are not claustrophobic, they are not difficult to use. So accordingly, the number of students per classroom, compared to the classroom area, has to be submitted, and these calculations are there for you to see. Talking of indoor comfort and convenience, we need to make sure that the anthropometrics are taken care of. In our case, we designed each classroom differently. The furniture of each classroom was designed differently so that the size of the kids for each and every class was properly accounted for while designing the chairs and the tables for them. So this is what we demonstrated for each classroom. There were different type of furniture arrangements and furniture designs and furniture sizes. Even for the washrooms, the heights and the sizes of the facilities were accordingly done. For the public,
sorry to disturb you again. We are running a little short on the time. So if we can come to kind of concluding remarks for the presentation.
Yeah. So all these, I've just touched upon all the basic facilities. So these are, the dust-free environment and all. These are things which are for the management and for the administration too. So certain images of the buildings. The toilet facilities, of course, are there. Yeah. So already touched this. So after having, taken care of all these elements, we have been able to procure almost 80 points for out of 100. And on that basis, we have been given a platinum certification. So that is what the end achievement has been. And after having gone through this process and, taken care of all these aspects in a very structured manner, I feel that, this is something which all of us can, because this was our first attempt. And if properly attempted with a good teamwork, this is something which is not rocket science, and all of us can try and adopt these methodologies and get the certifications of, and also feel as responsible citizens and responsible technocrats, doing buildings which are friendly to Mother Nature. Thank you very much for your patience. Thank you.
Thank you so much, sir. One query was there regarding how many are the satisfactory results. What are the minimum marks in IGBC system? So I guess you have just shown that 80 marks have been achieved, and that has been given a platinum rating. So that was addressing the same.
Yeah. So they start with silver, and then they go to gold, and then subsequently they go to platinum. So silver is the minimum rating in which 60 odd marks are required, which is something which is not at all difficult, given the type of support and hand holding which one gets from IGBC. I think all of us could, try and at least achieve that much, and try and do buildings which are friendlier. Yeah, and they don't add too much to the cost. That's what I also want to assure. They don't want to add too much to the cost of the building, which is something reassuring for the people who are promoters and developers, and our clients in our case. I've been more than happy to adopt all these things, and they've not minded the additional cost at all, which was not much in fact. Yeah.
That's what comes in mind whenever a platinum rating building comes, that how much will be the one-time cost. That's a concern to many people. It may be, from my opinion, it may be around 20 to 30% more, or is it lesser than that?
Actually, it all depends on how you assimilate the design and all that. 25% is actually, I think on a higher side, I would assess it to be below 20% if things are properly managed and designed from the design process itself. When things are done in a retrofit situation, then sometimes the cost escalations happen. But when you integrate the entire process in the design itself from the beginning, then I would think that between 15 and 20% cost escalation, you can achieve a platinum situation. Yes, there's no doubt about that.
And surely the savings in maybe next 20 to 30 years, you will be getting much more.
Of course, absolutely. And also the satisfaction of being there in a building which is, which is good for your health and for your well-being and everything. Yeah. So that is a huge achievement.
Yes.
Yeah.
One comment was coming that if there isn't any disqualifying criteria also there in the IGBC platinum rating or in the ratings. So
yeah, see, they have they have certain things which are compulsory. So in each category, like I said, in all the verticals, there is something which is absolutely compulsory, and there are certain things which fetch you points. So if there is something which you are not adhering to, something which is compulsory and that you are not adhering to it, that is not allowed. So you need to conform to those compulsory aspects, and then after having responded to or conformed to all those things, then you need to additionally get those points by giving your inputs and all that. So there are certain things in every category. Once you go through the IGBC document, you will see the the minimum compulsory aspects which you need to conform to in every vertical which I talked about.
Correct, sir. So, sir, we once again congratulate you to completing this building in a platinum rating and in a brief time and with a very cost-effective manner. So, it will be my humble request that if you visit sometime whenever to your hometown, you do visit us also, and we can have maybe a more elaborate discussion on maybe one or two aspects, because students may not be able to catch the calculations in this brief period which we had.
Yes, I understand. Sure.
That kind of personal interaction, if we can have some time for our students, that will be great.
Yeah, we'll coordinate, and we'll coordinate it very shortly, and I'll get back to you. Sure.
That will be great, sir.
Thanks.
So once again, we thank you so much, sir. With this, now let us move ahead for our third and last presentation for the day, and it will be delivered by Mr. Harshit Bahl, who is the Director Technical for Suntech AG. Mr. Harshit is a serial entrepreneur, leader, and strategist. He's an expert in developing technology, growth hacking, negotiating through effective business communications, getting things done by focusing on operational management, and passionate for product and process design. He has developed and designed air grow combining the best of air purifiers, humidifiers, and plant valves into one innovative product. AirGrow creates solutions to enhance the connection between nature and human-friendly environments indoor. Today, he'll be delivering his session on green walls and biophilic design. And with this, I would like to invite Mr. Harshit Bahl here on the podium and start with his presentation. Over to you, sir. Yes, sir.
Can you hear me?
Yeah, we are able to hear you very nicely.
I thank you for the introduction, and I'm quite happy to be here with you all. I think we have already gone way past the time that we were supposed to.
You can please go ahead with it. Nothing like this. You can please feel free to have your presentation.
Okay.
Audience are very patient, and I thank audience also to give us a little more time than what we were supposed to take.
Just a bit.
Sure. We'll share the attendance link also very shortly, as has been asked in the chat repetitively during the presentation. You can fill the feedback form and your questions and queries if there are some. And regarding the presentation materials, if we are able to get it from the speakers, we'll definitely reassure that we'll disseminate it with you guys. Thank you once again for your patience with the sessions getting longer, but I hope these sessions are very informative and these will be beneficial for your future growth. Yes, Ashwani. We are able to see your PPT now in full screen mode.
Yeah, so this is on biophilic design. If we talk about, like, if we ask the people that what is that they would feel happy about if they are in certain atmosphere or environment. So since this is not a live in person, so we could have a hand raise and an interactive session about that. But normally what people are happy are, like, right now we are sitting in our buildings or inside the rooms or offices. So the preferred area would be to be in the mountains or in the nature or somewhere near the ocean. So instead of having that, sometimes when you go out, our building should have these features inside it only, so that it is better for our mental health and our productivity. This is a small video that I would start with. So what biophilic design is. So basically human beings should be happy in the nature only. That is the basic criteria that is required. Natural life, that is what we want in our building. Having plants and natural material as much as we could use. in case of a business, like in case of a office building, like the major cost that they have, the energy cost is only 1%, 9% is the rental cost, and 90% is basically the salaries, the human resource cost that they have. And if we could improve their work conditions, they perform better, and even a 10% variation in that would be huge benefits for any organization. The same applies for the schools and colleges and residential areas also. So why now the biophilic design? Because stress-related illness primarily caused sickness by 2020. This was WHO, and right now after having this COVID and people sitting indoors, their health has been deteriorated quite drastically. And we were spending like 100% of the time indoors. Normally also, we spend a considerable amount of time indoors, and those places need to be designed in a certain way that our health is better in those areas. And in learning spaces also, if we have the right connection with the nature, then you have better cognitive abilities and increased ability to focus and reduce symptoms through attention deficit disorder, reduce stress, and aid in mental and physical recuperation. And key benefit is construction of biophilic design is contact with nature. So the more in contact we are with the nature, the more happier we would be and more better our mood and everything would be. And so the natural materials and all those, and that is how you design a building that is better in all sense, for which is designed actually around the people who are going to occupy the building. Not the building has been designed and people are put inside those buildings to stay or live or work. So there are 14 patterns of biophilic design. This would take a time, but normally it is visual connection with the nature, and non-visual is your smell, the sound, and all those things. And thermal airflow, these are basically normal. Anybody could search this and go into details because this would take time. So I will skip this, but this is an important thing. So 14 patterns of biophilic design is important. A direct connection, these are multiple studies and new are coming in post-COVID also. And so I will still skip. I will go to the main part and further. The green in the interior spaces. So this can improve your mental health. So this, even if we imagine to be in such place, we would, our emotions and our hormones would go in a positive way. And so these studies are there, but you can naturally also understand why this would be happening. And there are multiple studies. And as the previous speaker also told about the natural light exposure that is required. So because these are associated with our cardinal rhythms also. And so when we have the natural light, it automatically has those color variations that are required. And so this is the cardinal rhythm. So in the morning, you have different colors that are required. And as you go towards the evening, they are mostly towards the bluish tone and starts with the reddish tone. And this would actually have a very big impact on people. In case you change the color tones against the nature, then people have very difficulty living in that space. And the body kind of rejects this because all the systems that are inside our body and the hormones, they tend to go on this. This is natural lighting, how this could be incorporated. This is again human spatial response prospect. So different studies are there. I would still skip this. I will go towards what practical we are doing right now. Because these studies you can always find online, and no point covering too much since we are already in a time. So workers in office environment with natural elements, so they are reported for 15% higher level of well-being and 6% more productive and 15% more creative. In case they are sitting in a dingy office, then their productivity goes down. And so biophilic design enhances education environment, reduces stress and heart rate and blood pressure. So, and enhances focus, concentration. These are all things that we could understand very easily. This is what.
Hi, this is Harshit from Suntech AG, and I will be explaining you how the airflow system works. And this is a small video explain.
What is the most advanced green room? What is the most advanced green room technology on the planet? Indoor air is absorbed through the unique root system of the plants into an inorganic growth medium which needs no traditional soil. Microbes in our unique root system purify and cleanse the air from harmful chemicals, producing pure, clean, fresh air at the perfect humidity level. And we use only allergen-free plants as a fully automated watering, airflow, and lighting system, creating the perfect ambience.
So here on the right, we have a diagram explaining how the airflow system works. On the left, we have the image of the new.
Ashwani, I'm quite sorry to interrupt. Your voice is a little breaking and maybe it's not coming at as properly.
So I go again back to the right side of the image. So the air is being absorbed through this biofilm.
Can you hear it?
Of the plants. And in the air, you have the VOCs, which are mostly
Coming from
hydrocarbons.
two sources, I guess.
Yeah.
Are
So
then
this is
absorbed by the nanocharcoal medium that is placed inside. So the plants are growing in a nanocharcoal system. They do not have any soil in it, and even no cocoa peat is there. So then we have the microbes that have been already inoculated in these root zones, and these microbes break down these hydrocarbons into sugar and starch, which is then taken up by the plant as a food, and the plant grows. And the byproduct of this will be only the old leaves of the plants that will be falling down, so that those have to be cut off and thrown away, or composted to make a good compost of them. And then we have the sensors measuring everything. So now we have made an AI system which can manage this 24/7, and since due to the units that have already been installed and the data coming to us on our servers, we can also make it work without the internet connection. So since we know on what parameters it has to work, so that can be already encoded into it and as artificial intelligence, and it will be working on it. So how the airflow system looks. So below is the water tank system inside, and from the top the air would be coming out. And this whole wall of plants is a biofilter. And then you have its own grow light system. So the lights have been adjusted to the frequency acceptable for the plants. Normally they prefer blue and red light, and blue light is much more preferred for the photosynthesis, in which we have more of the leaves coming in. In case we want to have any flower or fruit from the plant, then we need red light. So normally a purple light is being made for the grow systems. But what happens when we grow vegetables, we use that, and since we do not have to think about the visuals, so in this around 10% of green has been added. So it goes towards the whiteness of the light, and so that it is soothing to the eyes of the people who are moving around it. So that's the main purpose of this. So this is the custom system, how these systems can be incorporated. Normally custom systems are developed when we design a new building. So then we set the architects and incorporate these in the initial stages. So the freestanding is what the airflow system. So they can be placed anywhere inside any building. any room, and they are ready to work from day one. And then we have a hybrid system in which we make a system which is then connected to the air supply system, the HVAC system. So that can be done for us, like for each office or each area, and it can be supplied to that area. And then we have a fully integrated system in which we have a bigger green wall system, and that is connected to the HVAC system, which then supplies air to the whole of the building. Normally, what happens in your existing HVAC system also, you'll be taking 10-15% of the air every cycle from outside, which is then again cleaned and then put inside the system, and again it has to be cooled down. So that is a very major cost for cooling. So with the help of these indoor biofilters, we can produce our own new air that is required. So since we are taking oxygen, giving out carbon dioxide, the plants are doing the reverse, and they can balance it out. Only thing is, in case we put them on the floor, so the amount of plants required would be much more higher. And since more of the air purification happens at the root zone, so the root zone has to be exposed to the air, then only it works. So this hydroponically managed system is a single plant can work 10x very easily due to the vacuum being well up behind it and air being pulled through the root zone of the plants, and plus the activated nanocharcoal over there. So this is one of the offices. This is the Bhajanlal Global Impact Foundation office. So this office has 0 windows, and they had around 60 people inside, sitting for 60 people. And this is a biofilter installed, and we are circulating air through this system. And if we see at the bottom side of the green wall, there is a sitting area, and below that is the whole watering and stacking system, plus the control system are below that. So this wall supplies air to this whole system. And these are the multiple. So this is the recreational area on the top. This is the initial iterations of the Airvo 1. So this you have in 6 feet height and 8 feet height also we were making. Now, since we have false ceiling, so this we prefer to go for only a 6 feet height system. So, but what we have done is increase the quantity of plants that are coming. So it is coming put to the 8 feet high system in a 6 feet system. So this is a burnt wood framing that we specialize in. This is a Japanese technology in which what we do is we burn the wood, and the sap of the wood is taken out by burning it, and only the grains are left. And then we scrub it off, wash it, and then we have a raw raised grain open pore wood. This wood can now not be eaten by any, or rotting of the wood is not possible. The thing that we have to do is dip them in oil. So once they are thoroughly oiled and they seep in, the oil seeps in, then they're ready to be used, and you get a very good combination with the green and the wood. So it is just like a tree bark that you have, and a natural texture, and no coatings or nothing is required on this, and this will remain like this for many years. Only thing that you may have to do is reconditioning. In the reconditioning, what we have to do is just give them more oil. So for example, with the weather and the water falling on that, the oil can come out, and after 1 year or 2 years or every year, a little dab of oil is required on that. So this is a Procter & Gamble campus in Bali. This is the outdoor system. So I'm just showing one indoor and one outdoor. So this is from outdoor, they are taking in air, and this is a picture on the day we installed it. And then after around 35-40 days, went for the first maintenance and to cut off the growth that is coming. So this situation over there.
So this is a small indoor unit. This basically is a tabletop system in which you could grow your plants, and this does not require any sunlight outside. So in your offices or any place on your desk, you could have this, and this has a self-watering system. So once you top it up, for next 15 days, it doesn't require any water, and all your plants will be growing in this only. This is the first. This has been made initially with the scrap wood, the waste wood that we get from the packing material, and in this wood only, this whole planting system was developed initially, and now the final versions are basically made on CNC again with a re-engineered wood system. And this was again waste product, the ply wastage that we have in one of our factories. So when we do interiors, whatever wastage is left, these planters have been made with that only, and they basically manage your plant. So you do not have to worry about taking them out or anything. They have the natural light frequency that is required for the plants to maintain their health, and they keep on growing inside. The only thing is the water has to be topped up after some time, depending upon how much air conditioning you are using. In case you are not using the air conditioning, the time goes up to like 20 days. And in case the air conditioning is used extensively, then because it will be taking out the moisture a lot, and then it could go down to like 10 to 12 days. This is my factory only. So this is the common wall. This is one of the massive walls that we have. Actually, there is a double wall of this size only. This wall is like 7 years old, and this is not being made in any plastic pots or all those things. This is made in a fabric, and this is what actually we use in indoor systems also, because the major thing is the plants needs to breathe through its root zone. And in plastic cups and all those things, the major problem is you cannot have this kind of a density of plants. And secondly, because after sometimes there would be a root coil inside those plastic pots, and they will start dying. So normally, whoever has experienced like with green walls, initially they look good, but after like few months only, they start drying up. This is also a hydroponic system. So all the water that goes into it is recollected. So this works on only 10% of the water. So 90% of water is saved in this, and whatever excess water comes in is recollected in a sum and then recirculated as and when required. We have two systems. One is a basic timer system, or a second in which it connects with the internet, and according to whether it keeps on giving the water and the temperature that is coming up over there. And this is from the other side. This
air grow technology that I'm explaining has many awards, and we were awarded by the Union Home Minister, Mr. H.S. Puri, for innovating these smart grid technologies. And this is me, Harshit, and this is my contact number. So we have a big factory in Panchkula, Haryana. So 3-4-5 minutes to India. And if you have any questions, you can ask me or mail me. I can respond to that. Thank you.
Thank you. Thank you so much, Harshit, for your brief and very effective presentation on biophilic design and proper solution to it through the airflow. So there is one or two queries which are there in the chat box. First is regarding, will this system attract any kind of insects or maybe which may be bad for humans or something?
No, why? Because if in case it is outdoor, then it would be no issue with that. Because that would be coming in. And what we do normally is the water, in that water only we have retarders for these insects, because other insects, and normally the plants that are used, they are not edible plants, so normally they do not get in those kind of insects. Only thing is the mosquitoes and all those could be there, but for that, since this is a recirculatory system, so the water is constantly circulating in this, so those also don't come. And when we go for the indoor system, so in the indoor system, once that plant has come in, it is sterilized first, and this is not growing in soil.
Okay.
This is growing in activated charcoal. So this is a hydroponic system. So in this, if you put any medicine in the water, that also sterilize that. And once it is sterilized, then there is no chance of insect coming in until unless you have like things open and the insect coming. That is natural. Then again, since this is it's very easy to disinfect it. Just put few drops in the water, and since it is circulating all over, so it would kill off anything.
There's one more question. I think the question contradicts itself. Or it is asked that also the design requires a lot of space as per your first few slides. Will be suited for urban or rural areas?
So this is basically going vertically. So we are covering the wall. Yeah, for example, in the one that I showed in my factory or Procter & Gamble. So these are like, this is a common wall between my factory and the other factory. So in other cases also. So this only takes like 6 inches for the system. And then the plants also come out like 6 inches more. And then, so that is a very less. And like in my factory, I have more than 90,000 plants in these walls. So, and they are like growing, and they do not die because their roots basically puncture the fabric. So they get from the below also. And water in, you cannot overwater it also, because when you water it over, it drenches out and goes back into the sun. So even if we keep it on for the whole day, that is, it is a space saving.
Yeah. So it's a space saving solution and a very wonderful solution. What are the cost implications like for a 6 feet by 6 feet panel? What in what range generally these systems comes up?
So it depends upon what system we are going for. So for a non-active wall, in which we do not do the air purification and the vacuum system, because that would incorporate more fans and all those things. A normal wall would be like 700-800 rupees per square foot. And as the sizes increases, the prices go down. And in case we have this active wall, that could go higher. For example, in case it is a custom-made wall for the area, it all depends on the size, because the pumping and all those things would be one only.
Yeah.
For a small system also, for a big system also. So that is, again, it depends on what area we are going and how vertically we are going. So in case we do not go more than 8 feet, then small pumps work. If we go like more than 1 story, then other pumps, and multiple pumps are also required, so that in case one fails, we have a backup always.
Yeah. So I hope so. This has been a patented product, or these kind of some other rivals
These
are
applied for patent of this.
Okay.
And we basically
is this the only way to make green walls? Or what are the other industrial way approaches to making green walls, which we are seeing in different...
Which you are seeing normally is the plastic pot that is on a frame. And the only problem is because it has one drain hole in it. At the base. And that drain hole basically chokes after some time, because the soil is going to compress in that. So the one we saw in the Kara school, that presentation also. So after sometimes those pots would actually choke up. And so they require, so when that is a small wall, still it could be managed. When we go bigger, so somebody has to climb up and see which choking is happening. So that is a big problem. those.
Yeah.
Plus, we have a direct sunlight coming on those spots. They would heat up and the root zone because there is very less soil quantity in that. So during summers, they dry up like anything.
Yeah. So we'd like to invite you to our campus in JP University, Vatnaghat, and have a few more ideas which we have for medicinal plants, because this environment is very much suitable for medicinal plants.
Yeah.
And if we can develop this for indoors also, that can be a breakthrough in this.
So when we have, so I am an expert in hydroponic systems. So the only thing is when we do the ornamental plants, the nutrients requirement is not that high and that's specific.
That I understand.
That we would have to have few more sensors, and the EC and pH of the water would have to be maintained. And we will have another thing that is required, that is a dosing system that would be required. So because in case it is a normal leafy plant, then it is easier.
Yeah.
The some plants which would be flowering and fruiting would require a specific.
Yeah. That will be specific lighting will be required, specific nutrients will be required. But certain medical plants which we are developing in our biotech department over here are leaf-based, and they are of very much use in various medicines.
Right. And for the insects also, if we put in few plants which are these, so they repel those insects, and we could have that also insect. The only thing is the specific requirement of, because ornamental plants are very easy to grow, and they grow. They just need the light and the water, and they work. And we try not to give too much nutrition also, because it will be more job for the people like to cut that off. So that is good.
Sure. One request was coming from our students is regarding if they can visit you sometime, or some kind of exhibition can be made where the students can see these green walls in action, or the airflow system.
Yeah, they could just call me up and fix up a time. So this is basically, I'm into interiors also. So my dad is an architect. I'm a mechanical engineer. So we have the factory over here.
Yeah. I'm testing the patience of my audience. So thank you with this note once again. So taking your good amount of time and letting us know regarding the airflow technique which you have invented and which is patent pending, as you are saying. So once again, we thank you, and we definitely will welcome you if you can sometime come up to JP University Vatnaghat, and we can have more sessions like this.
Thank you.
Thank
you for having me.
So with this, we come to an end to our sessions on the latest trends in green buildings. So from the beginning, it has been a very informative webinar session. In 3 different sessions, we have seen how green buildings are evolving with the use of latest AI and machine learning techniques, with the use of various sensors in the buildings, which has been delivered by Mr. Ashwani Bamba, how different players are coming and how it is becoming more globally available, and rates are also going down. Then we have seen a very beautiful case study of Chitkara International School by architect Sukumar Jairath. He has given a wonderful presentation how they have achieved a platinum rating. And in the end, Harshit has given us a very wonderful biophilic design and green wall technique, and his patented air grow technique, also how their green walls can be made. With this, we like to once again thank all of our participants and all of our speakers for today to be so patient and kindly give this information. At the last, we'll also like to inform that JP University of Information Technology is still giving on-spot admissions against few leftover seats in our BTech programs in civil engineering and civil engineering with computer applications. Also to our MTech programs in construction management, in structural engineering, in environmental engineering. Also, lastly, on the BTech lateral entry seats are also on offer up till 30th September, and only availability will be based on how many seats are remaining. So if some of your knowns are still looking for an admission, they can look up to these programs. With these words, we thank you with heart to attend this session. And we are also grateful that you are filling the feedback forms. Those who could not, we will again share the link in the chat box, and that will be the case for today. Thank you once again for attending this webinar, and we'll be again be in touch with such more programs. You can give your constructive feedbacks to us, what kind of programs we can bring for all of you. Thank you. Thank you all.